Okay, we're on the second part of heat transfer. We're going to discuss um, transfer by convection. Let me dismiss my image, and we're the convection is a transfer of heat involving only bulk motion of fluids. That can be air, or that can be water. Um, uh, Example is the visible shimmer of air above a hot stove or above asphalt on a hot day. Visible shimmers in water due to temperature difference. I know when I boil eggs, um, I don't like to put the eggs in until it's fully boiling. So I peek in and I can see just before it gets to boiling, I can see almost swirls in the water, and that comes from convection currents in the heating water and differences in hot and cold. Uh, it hasn't all it doesn't have a uniform temperature yet. It's still rising and getting to a boiling point. Um, Okay, reason warm air rises. Warm air expands, becomes less dense, and is buoyed upward. I think you probably heard it all your life. Warm air rises, and it's true. Um, it becomes less dense and it goes up. It rises until its density equals that of the surrounding air. Example: smoke from air. I'm sorry. Smoke from a fire rises and blends with the surrounding cool air. Uh, and we'll see that as it expands, it also cools, cooling by expansion. Opposite to the warming that occurs when air is compressed. If you compress air, it warms up. If if you have a hand pump bicycle tire, you pump it. Part of that comes from the friction, but part of that just comes from the compression of the uh, the air, and it's heating up the pump. Um, so the example of warm air cooling, when it expands, the cloudy region, you can see this lady put her hand over the what looks like steam, but steam is actually invisible. The cloudy region above hot steam issuing from the nozzle of a pressure cooker is cool to the touch. It's a combination of air expansion and mixing with cooler surrounding air. Now, the part right above the nozzle that you can't see, that's at high pressure and that's at high temperature. So don't touch that. So the before we get to that, as the air expands, the speed of the um, molecules are they're bouncing off each other, but as the air expands, they're bouncing off of air molecules that are receding, that are going away from it, so that it diminishes the overall kinetic energy and it cools. So if you lower the kinetic energy, then you have cooling. Okay. Although warm air rises, why are mountaintops cold and snow covered, while the valleys below are relatively warm and green? Is it because warm air cools when rising? Is it because there's a thick insulating blanket of air above the valleys? Is it both A and B, or some other reason? None of the above. Well, it's C, both um, A and B. Earth's atmosphere acts as a blanket, which keeps the valleys from freezing at nighttime. Further higher up the mountains, there's less atmosphere, so it doesn't act as much as a blanket up there. Okay, winds. Winds are the result of uneven heating of the air near the ground. The absorption of sun's energy occurs more readily on different parts of Earth's surface. Um, we discussed in last the last chapter how uh, the the thermal the thermal coefficient is lower for land than for water. So water takes a lot of energy to heat it up. Land not so much. So the land's going to be hotter during the day, and the water will be cooler. Now, the opposite will be true at nighttime. The because it has a lower specific heat capacity, the land will give up its thermal energy quickly, where the water, because it has a high specific heat capacity, it'll retain what temperature it has for a longer period of time. Um, the sea breeze. The ground warms more than water in the daytime. Warm air close to the ground rises and is replaced by cooler air from above the water. And you can see that showing it in the opposite direction when at nighttime. Okay, and that's all we have to discuss on the convection.